Hi, I'm Andrew Williams, and this is my tutoring assessment. This is Victoria. She has chosen CH3CL as her tetrahedral, PCl6 as her octahedral, and SF4 as her trigonal bipyramidal molecules. So now let's talk about these. We kind of already went over this, but question number one: what electron geometries do these molecules have?
This one is, the first one is tetrahedral.
Mm-hmm.
The second one is octahedral.
Mm-hmm.
And the last one is seesaw, or...
Well, that's the molecular geometry.
So... Or trigonal
biplanar?
Bipyramidal?
Bipyramidal, right.
Bipyramidal.
Okay. So now using our big jet puffed marshmallows as central atoms, our small bunny marshmallows as the other
atoms,
and the pretzels sticks as this records sound, right?
Yeah.
Okay. As the bonds. Let's get to work building them.
Okay. So this is my central atom.
Mm-hmm.
And then we're going to use pink, the pink bunnies as the hydrogen.
All right, I'll help you pick out some pink bunnies. There you go.
Thank you.
And what do you want for chlorine?
And chlorine, purple.
Good choice. Tasty choice.
Tasty choice. Oh, good. And
So we got 3 pinks and a purple. Very good. Okay, let's move on to the next one. PCl6.
Okay, this is going to be the phosphorus. It's going to be the giant marshmallow. I'm just going to go ahead and put 6 sticks in here.
Mm-hmm.
If they'll all fit.
Try and get the angles to be as good as possible, as true as possible to the 3D shapes.
That's 4. Oh, that's right.
All right.
And then
What are we going to use for
green?
Greens. 2, 3, 4, 5, 6 greens.
I feel like Wednesday Addams playing with my food.
So that's what an octahedral molecule looks like. You can set that down without messing it up too bad. Oh well. Alright. There's some more pretzel sticks for you. Alright, and lastly,
We're going to make a seesaw. Or
gonna
the
make our seesaw.
trigonal bipyramidal.
But we're also gonna put on our lone pairs.
And our lone pairs, yes.
Okay.
So, we're going to have these.
So those two are your axial.
And that's going to be my lone pair.
Okay. Try and get 120 degrees.
Okay, there, right?
It does go out to the side. On the same plane as this one, remember? Oops.
My God. Oh well.
We got plenty others.
And then... But it can...
Should be 120 from each other.
Oh.
So like, and then this one would be like out
Up there.
there.
Okay.
Okay.
It's a little short.
So this one's our lone pairs, you said?
Yeah.
Put on whichever ones you want.
Okay, there we go, little bunny.
Okay.
That's my lone pair. And
What
then-
color is the fluorines?
And the fluorine will be purple.
Okay.
Thank you.
Mm-hmm. All right.
And
So
this is
to
like,
see what the molecular geometry would look like, we'd take off that lone pair. Okay. So now if you lay it down like this, you can kind of see how it looks like a seesaw. Okay. So let's go to question 2 now.
I'm sorry.
What molecular geometries did each of these have? What did the CH3HCl have?
Molecular geometry. It had.
Molecular geometry is the one that changes from electron geometry if there's lone pairs.
This one did not have. Well, it did have lone pairs
Well,
around the.
that's not a lone pair. That's your chlorine atom. So did its geometry change any?
No.
So
Yeah.
then it.
No, because it didn't have any lone pairs.
Okay. So then it's still
It's still a tetrahedral.
tetrahedral. Okay.
This one did not have any lone pairs
Okay.
because it did not have any lone. It's not.
Didn't have any lone pairs.
Didn't
So
have the lone pairs, so it's still an octahedral.
okay. This one was originally trigonal bipyramidal,
Yes, but
but it had lone pairs.
yes.
So
So, like Andrew showed you, it's seesawed.
okay.
What is it, seesaw?
These two. These two.
No.
Yeah. Okay. So now on to question 3. Is your molecule polar or nonpolar? Is this one polar?
Definitely not polar
Why do you say that?
because it's got a lone pair.
Doesn't-
And anything with a lone pair means that it's not polar, not nonpolar. It is polar, very polar.
Yeah.
Oh yeah, I'm
Yes.
sorry. I always get them confused, like nonfiction and fiction. It is very polar.
Yeah. Yep. What about your octahedral there?
The octahedral would be very nonpolar because it's all equal.
Everything's going to balance each other out. Yep.
Yeah, it all
Okay.
balances.
What about your tetrahedral one there then?
This is non-polar.
Why
I mean,
do you say
it is
that?
polar.
Okay, why do you say that?
Well, it would be non-polar if this was also a hydrogen atom, but it is not.
But it is not, so these two.
It does not balance it out.
Okay, very good. So then, what is question 4? How many pi bonds are in your molecules?
Pi bonds. Okay, this has 1, 2, 3. Does not have any pi bonds. It has 4 sigma bonds.
When do pi bonds happen?
Pi bonds occur when when a double or triple bond occurs.
Yeah.
Thank
Yep.
you. Was that easy?
Yep. So then, do we have any pi bonds in any of our other ones?
No, there are no pi. Well, I mean, yes. No, we have no pi bonds. We just have sigma bonds in all of these.
Okay. Cool.
And number 5.
So then, yeah, what are the hybridizations like?
What are the hybridizations?
Yep. What do the hybrid orbitals look like?
Hybrid orbitals. We've already signed out.
But like a lot of times, well, in that situation, it was
Hybridization. Oh, with the
but like a lot of times with like
the balloons.
Yeah, like the new.
Okay, well then these just have a single balloon. Right? Oh, okay.
Okay.
Oh. All right.
So then, like, what is that one?
This one has SPD3. SP3. SP3D2.
Okay.
And
And what about that one?
this one has SP3.
Very good.
And then this one has SP3D.
Yep. Because the hybridized orbitals were is all about electron groups, so lone pairs do count. All right, very good. Now you are free to enjoy your snack, your tasty chemistry snack.
Well, thank you.